Well, hello again. We're about to go on to some other information about Fibonacci numbers and discoveries with it. And before we do, I thought we'd take a moment and do a little bit of review again. So to help you get ready for the test that's coming up, let me get my picture out of here, just in case yours isn't up in the corner. I want mine to be up in the corner out of the way. About how many folds of a single piece of paper rolled over on the sides? In other words, after we folded it and it's big stack like this, we're going to roll it over, okay? How many folds of a huge piece of paper would be required to just exceed the length of a standard football field? Whoa. Okay? How long is a standard football field? We're going to make this stack and then we're going to roll it over. How many thicknesses would we have? How many times would we have to fold that big, huge piece of paper so that we would stretch that thickness entirely across the football field? Well, let's look at how long a football field is, right? A football field is 100 yards long, right? But with the end zones, where the touchdowns are scored, we have an extra 10 yards at each end, correct? So it's 120 yards long, okay? So we want to stretch the whole field. So we're going to start with 120 yards. And we've got to get this into the number of pieces of paper that we'd have thickness-wise stacked on top of each other with these folds to equal 120 yards. Well, we got to go from yards down to what? Down to inches and then into sheets of paper. Well, if you recall from a problem we did earlier, there are 36 inches in a yard. So we can go right to that instead of going to feet first and then to inches. So if we go 36 inches exist for every 1 yard, we'll put that on there. Now this answer would be in what? In inches. Now I want to get it into sheets of paper, right? Sheets of paper. So how do I do that? Well, if you recall, for every 1 inch of thickness, there will be 250 sheets, right? So if I multiply this out, I will have this answer in the number of sheets of paper that would be stacked on top of each other and then turned sideways, or the number of thicknesses I need to have this happen. So I'm going to turn and use my calculator back here. So I'm going to multiply 120 times 36 times 250. When I do, I get, it looks like 1,080,000 sheets of paper. 1,080,000. Now, if you did this on your calculator while I was doing it, you want to make sure I haven't messed up and I got the right answer, and it appears I did. Now, how do I get this into the number of folds I need? Well, if you recall, it's a power of 2, right? Every time you fold a piece of paper, you've doubled its thickness, all right? Therefore, it's exponential growth using powers of 2. So 2 to what power would be greater than or equal to 1,080,000 sheets of paper thick? All right, trial and error time again, right? So I'm going to take my other calculator out from over here, and I'm going to do some powers of 2. Why don't you play with it too while I'm doing it? Let's see if we can find something here. I have tried 18 first, and 18 gave me 262,144. I'm a little short, right? So that's not going to work. So I'm going to try maybe 2 to the 20. If I do 2 to the 20th power, I get 1,048,576. So that's almost enough sheets to make the football field, right? But unfortunately, we're going to have to go one more, right? So if we do 21 folds of that piece of paper, we would get an answer of, let me clear that, it would be 2 carat 21, and that would be 2,097,152. We'd be way past the length of the football field, all right? But we would certainly have done enough folds to be the length of the field or greater. So really 20 folds would be closer to the length of the football field, but you know we'd have to go to 21. So that's just a quick review question. Of course, something like this will occur or appear on your test that I will be giving you on Friday. So I figured it wouldn't hurt for us to just take a second and review it. Okay, a couple other questions I'd like to ask you. How do you write the reciprocal of a number? Well, if you recall from middle school or high school, the reciprocal of a number like 28, you simply take the 28 and stick it what I call downstairs. It'd be 1 over 28, right? So the reciprocal of 28 is just 1/28. It's the number you would multiply 28 by to get the answer 1. That would be its reciprocal, right? What's the reciprocal of 9/10? Well, if I do the same thing, it would be this. But if you recall, if I divide 1 by 9/10, you have to flip the number you're dividing by, which becomes 10/9, and your answer is 10 over 9. So in other words, what do you do with that fraction? You just flip it over, right? So in other words, 9/10, the answer becomes 10/9. Now, the author, Dr. Ed, is going to be using the concept of reciprocals in his discussion of something that's coming up very shortly. So I'm doing an introduction to get you kind of ready for that. How about 1/12? What would it be? Well, it would simply be what? 12 over 1 or just 12, right? Because 12 over 1 and 1 over 12 would multiply together to give you 1. What the heck is the reciprocal of that last thing there? Well, that's a little bit harder, and you're going to be seeing some of these in the video that's coming up. What you do is you take that whole thing, and you stick it on the bottom and put 1 on the top. So it's 1 over all that stuff, okay? So we're going to be seeing that in the video discussion that will be coming up shortly by Professor Ed, okay? So just keep that in mind, all right, for the future here. Now, we're going to watch 2 pieces of a video by the author, Dr. Ed. And I'm going to tell you that I divided it into 2 pieces. And then in the middle of, after you've watched the first piece of it, you're going to come back to me. I'm going to explain some stuff. And then we're going to go back to Ed again for him to finish his discussion. Okay? So, with no further ado, we are about to have you go to your next video in your email, okay, which is called Ratios and All Ones, Part 1. Okay? So, I'll see you after you have watched that video. All right? Take care.